So far we have seen the two components of artificial neural network, the feed forward and forward propagation, and the cost function of the artificial neural network. In this video we will discuss the backpropagation and how it can be done. Recalling the earlier diagram where we have discussed neural network with four layers. The layer 1 is the input layer and layer 4 is the output layer. There are two hidden layers, layer 2 and layer 3. Each layer has different number of neurons. The layer 1 input layer has 3 neurons or 3 components, while the layer 2 has 5, layer 3 has 5, and layer 4 has only 4 neurons. Each of the neurons are connected with each other in different ways, and we will be using backpropagation to calculate the error caused, and we will be going in the reverse directions in the backward direction. That is why this particular method is known as the backpropagation method. Earlier in the forward propagation we started from the input layer and then we calculated A12, and then from A12 or the second layer we calculated the third layer components, and from the third layer we calculated the fourth layer components. In this particular backpropagation technique we will be going in different direction. We will be using the backpropagation starting with the final layer, that is the fourth layer. We will be calculating the error in the third layer, and from the third layer we will be calculating the error in the second layer, and so on for the multiple layers. We will never be calculating the error of the first layer, that is the layer 1. This does not need to be considered because we do not need to worry about that. It's an input layer and the error calculation for that is not required. In the next slide we will take one example and we'll try to understand how these errors can be calculated. These errors will be denoted by delta, small delta. As you can see, for the layer 4 the error is the delta 4, for layer 3 it's delta 3, and for layer 2 it's delta 2. Again repeating the same point that we will not be calculating the error for the first layer, that is the input layer. As you know that earlier we calculated the values of different neurons of each layer, and we had reached to the final neuron, say for example A14 here, and then you can have A24, A34 and AA4. This was calculated using the feed forward or the forward propagation method. So you already have these values. Now we want to calculate the delta 4 for this layer. And so the formula is very simple. Delta J4 refers to AJ4 minus YJ. Now this is nothing but it's basically seeing the accuracy level of the model. The Y is the value which you already have, and AJ4 is the component of the output layer, or which has been derived from the model by the forward propagation. So you derived something from the model and you have something available with you. So while you compare the two, you have to find out whether the accuracy is matching the criteria or not, or how much difference is there in between the derived values and the actual values. This can be calculated by subtracting the derived value and the actual value. So the fourth layer error can be calculated using the delta J4, AJ4 minus YJ. Moving ahead, we want to calculate the error for third layer. That is, we want to derive the error from delta 4 for the third layer, that is delta 3. So you already have delta 4, you already have theta 3. Theta 3 refers to all the weightages which had been available at the time of calculating feed forward, where you are connecting the neurons of third layer to the fourth layer, and then you have Z3. Z3 is nothing but it's the multiplication of theta and the value of the component. So in case of x1 it is x1 dot theta. You are calculating the error for delta 3, that is for this third layer, using the values which you have available with you. Delta 4, the theta is lying here, and the g dash z of 3. Z of 3 is the value of the theta multiplying by the component value. And similarly, you can calculate the values for the delta 2, which is based on delta 3. Now you have delta 3 and you want to derive delta 2. So again the same formula, theta 2 transpose delta 3 into G dash Z2. Dot asterisk, just to recall, it refers to the member or element wise operation, and it refers to all the matrix operations where the multiplication is done at the element level and not at the whole matrix level. So this backpropagation method allows you to calculate the error of each layer by backpropagating from the output layer to the second last layer. Again, we are not calculating the error of the first layer because it's an input layer and there isn't any layer need to be calculated for that.